So good morning students, welcome back. Today in this chapter unit and dimension, we are going to discuss application based on unit and dimension. Okay, generally there are three applications of dimension. Okay, the first application is conversion of one system of unit into another system. It means MKS to CGS, CGS to FPS, FPS to CGS or CGS to again MKS. Interconversion between the types of system of unit. Our first application base conversion of one system of unit into another. It means MKS to CGS, either CGS to FPS. If you remember, we did the three types of system of unit: M for meter, K for kilogram, S for second, C for centimeter, G for gram, S for second. F means foot, pound and second. So our first application, conversion of one system into another. For explaining this application, I'm going to give you an numerical. Okay, so let's start with the numerical. Question number first is convert 1 Newton into dyne. Convert 1 Newton into dyne. Newton is the unit of force. Okay, in which system? MKS. Dyne is also a unit of force. In which system? CGS. We did in the first lecture in this chapter. Okay. So Newton, we have to convert Newton to dyne. Newton is in MKS, dyne in CGS. Newton is unit of force in MKS system. Dyne is unit of force in CGS. Okay. For converting one system of unit into another, we are having a formula. N2 equals to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. Look at students, here N1 is the numerical value in first system. We are given convert 1 Newton. So 1 Newton is taken as N1. So N1 is what? 1 Newton. Okay. N2 is a numerical value in another system in which we have to convert. Okay. So we have to convert into dyne. So N2 is the value of numerical value in another system that will come in dyne. That we have to find. It means N1 is always given in the question and always you have to find N2. Okay. N1 is the numerical value in first system while N2 is the numerical value in second system. Okay. So N1 N2 has done. Now M1 is the mass in first system, M2 is the mass of second system of that physical quantity. L1 is the length in first system, L2 is the length in second system. T1 and T2 are the time in first and second system respectively. Okay. And A, B, C, that you know, the power of MLT, the exponential form, is said to be dimension. So first of all, you have to identify which physical quantity you are given. Actually, we are given Newton and we have to convert it into dyne. Newton is the unit of force. So we are given force as a physical quantity, force. And we know what is the dimension of force? M1, L1, T minus 2. We did in first lecture, and you can also find, if you don't know, you can find by this formula. Force, mass into acceleration. Okay students? If you don't know, now you know. Okay. So this is taken as power. So look at M1 by M2 power A, M power A. Okay. Comparison of both these equations, M power A, M power 1. So A is taken as 1. L1 by L2 power B, L power 1. So B equals to 1. When base is same, power will also equal. T1 by T2 power C and T2 power minus 2. So C equals to minus 2. This is the first equation, and suppose this is second equation. First and second. Compare in both the equations the power of MLT. You will get ABC. So it means power is always taken as a dimension of physical quantity. Here we are given force. So this is A, B, C. Suppose if you are given work, if you are given pressure, if you are given power, whatever, that dimension ABC is taken as its dimension. Okay. So this is A, B and C. We are given N1, we have to find N2, we got ABC. Now we'll discuss about mass, length and time. So one important thing is there, we are given MKS system that always come upwards. It means the mass, length and time of MKS system come upwards. And we have to find in CGS system. the system that you have to find always come in downwards. So mass, length and time of CGS always comes downwards. Understood? Given the value of given system always come upwards, the values of the system that you have to find always come downwards. Understood? So in M case, look at students, N1 is what? 1 Newton. So N1 is 1. In M case, mass 1 kilogram. In CGS, mass 1 gram. Power A is what? 1. As I told that given system comes upwards and the system that you will find come downwards. So MKS upwards and CGS downwards. In MKS length 1 meter, in CGS length 1 centimeter. Power B, and B is what? 1. T1 is time in MKS, T2 is time in CGS. In both the system 1 second and 1 second. And power C, C is -2, so here we will put as -2. Now students, we will solve this. 1 kilogram consists of 1000 gram, 1 meter consists of 100 centimeter. Second to second cancel out. 1 power -2. 1 power -2 means 1. Okay, so I have written here 1. Now gram to gram cancel out. 1000 only. This is 1 only. Centimeter cancel out. 100 only. Now count the 0. 1, 2, 3, 4, 5. 10 is power 5. And there come dyne. So basically what we got. Okay, we are given 1 Newton as N1 and N2 we are given as 10 is power 5 dyne. It means 1 Newton consists of 10 is power 5 dyne. Newton is a major unit of force in MK system. Dyne is minor, small unit of force in which system? CGS. So we converted MKS to CGS. One important point are there. Given system always come upwards and the system that you find always come downwards. That's why I have written here MKS the value upwards and CGS downwards. And the important thing, by the values we can get, by the unit we can get the physical quantity, and the dimension of physical quantity is taken as ABC. And the formula just remember, N2 equals to N1, M1 by M2 power A, L1 by L2 power B, T1 by T2 power C. This is the formula for conversion of one system into another. Okay students? Now students, we'll discuss the second application of dimension. The first application was conversion of one system of unit into another. Now the second is check the correctness of the formula. It means with the help of dimension, we can check the formula, either it is right or wrong. Okay, so look students, suppose you are given time period of a simple pendulum. You are given time period of a pendulum T equals to 2 pi root L by G, and you are given the data, information about the data. T is time period, 2 pi is number, L is length, and G is gravitational acceleration. Actually, this is the simple pendulum. L is the length of the rope that we are given as L. Okay, and M is the mass of pendulum. And look at this to and fro. Time taken in one oscillation is called time period. That we have to find. Okay, that we are given. T equals 2 pi L by G. And in this formula, you have to check whether it is right or wrong with the help of dimension method. So the process is we'll always find dimension of left hand side, then dimension of right hand side. Okay, if both sides having equal dimension, same dimension, the formula will be correct. If both the sides having different dimension, it will be wrong. So let's start the numerical students. First of all, I'm going to find the dimension of left hand side. At left, that is right hand side, and this left hand side. At left hand side, what we are given? Time period. And the dimension of time period is, there is no mass, M0, no length, L0. Time is always represented by T, so T1 will come. So we got the dimension of left hand side, M0, L0, T1, only time is there. Okay, we did in the first lecture, we found the dimension. You can check in that YouTube channel, in my YouTube channel. Okay, you will get the dimension of all the physical quantity. Now students, we'll come at right hand side. At right hand side we are having 2 pi root L by G. Look at students, 2 pi is a number. There is no dimension of number, all numbers are constant, so number will be neglected. So 2 pi will be neglected, 2 pi term will be neglected, we'll use only L by G. Okay. Now students, L is length. Length, okay, represented by L. Distance, height, radius, all represented by L. G is gravitational acceleration, but it is acceleration, and we know the formula of acceleration is what? Velocity by time. Change in velocity by time. Velocity we can write as displacement by time, and that time as it is. No mass, m0. Displacement written as L1. Time, t1 and t1. So m0, L1, t minus 2. That is dimension of acceleration. So we'll put m0, L1, t minus 2. Look students, mass, there will be no effect on mass. Mass remain m0, whether upwards or downwards. Look at L1 to L1 cancel out. L0 transfer t minus 2 upwards, it become t plus 2, and we'll take the square root. In square root, power become half. M0 no effect, L0 no effect, t2 become t1. Now check the dimension of LHS and RHS. At left hand side, M0 L0 t1. At right hand side, M0 L0 t1. It means the dimension of, therefore the dimension of LHS equals dimension of RHS equals to M0 L0 t1. The formula is correct because both the sides, left hand side and right hand side, having same dimension, so formula will be correct. Okay, in this way we can check the correctness of any formula. That is a simple basic example that I have given. Okay students, now we'll discuss its third application. Now students, we'll discuss third and last application of dimension, that is find the relation between physical quantities. Either derive the relation between physical quantities using dimension method. See, find the relation between physical quantities. So in order to explain the third application, we have to discuss a numerical. So now we'll start the numerical. An electron is revolving in a circular path around the nucleus. Okay, this electron experiences an attraction force towards the center, that is called centripetal force, and this centripetal force F depends on mass of electron, velocity of electron, and radius of circular path. And he is asking, find the relation between F, M, V and R, force, mass, velocity and radius, by using dimension method. You can take a screenshot, you can write the question. Now I'm going to explain this question first of all. Okay students, see, remember the sequence. Force F depend on mass, velocity and radius. Okay, MVR. Force depends on MVR. Now students, I'm going to explain. I'm going to remove the numerical. Okay, and we are going to solve the third and last application. Find the relation between physical quantities, okay, using dimension method. Look at, this is the center, electron is revolving around the nucleus. This is the nucleus. Okay, V is the velocity, M is the mass of electron, and R is the radius of circular path. Okay, and the force is working towards center, that is called centripetal force. And this force depends first on mass of electron. This force depends on velocity of electron. We have to follow the sequence. Okay, if you remember in the given question, first of all we are given force depend on mass, second we are given force depend on velocity, and finally we are given force depend on radius. Okay students, now when we combine from first, second, third, we will get F proportional MVR. Okay, whenever we remove proportional, we always use equal and constant. M power A, V power B and R power C. This will be the main equation, equation 4. Okay, actually we have to solve the relation between all these physical quantity using dimensional method. And what is the meaning of dimensional method? Power of MLT, the exponential form of fundamental quantity is said to be dimension. That's why I'm going to use ABC. ABC is power. constant having no power, that's why will not include in that dimension. A, B, C. We are given 3 quantities, so A, B, C. Suppose if you are given 2 quantities, you write A, B. If you are given 4 physical quantities, you write A, B, C, D. Understood? And now we have to find the value of A, B, C. For that, we'll put the dimension. Student, what is the dimension of force? The dimension of force is M1, L1, T minus 2. Okay. K as it is. M is mass. What is the dimension of mass? Only M1 power A. What is the dimension of velocity? Displacement by time. L1 T minus 1 power B. And radius is distance. So they come L1 and power C. Now solve this. M1, L1, T minus 2K as it is. 1 into A, M power A. 1 into B, L power B. Minus 1 into B, T power minus B. 1 into C, L power C. M1, L1, T minus 2, K as it is. When M power A as it is, when base is same, power will add. So L power B, L power C, L power B plus C, and T power minus B. Now students, compare both the side the power of MLT. M power 1, M power A. So A equals to 1. Equation 5. L power 1, L power B plus C. So B plus C equals to 1. T power minus B, T power minus 2. So minus B equals to minus 2. Minus 2 minus cancel out. B we got as 2. We got A as 1. We got B as 2. Now we have to find only C. So put in equation 6. From equation 6. Put here what is the value of B? That is 2. C and 1. Transfer 2 at that side. Minus 2. Minus 2 plus 1. Minus 1. So we got C as minus 1. Equation 8. So we got A as 1, B as minus 2 and C as minus 1. We'll put all these value of A, B and C in equation number 4 in this beginning equation. So write from equation 4. F equals to K M power A. What is A? 1. So M power 1. V power B. What is B? 2. So V power 2. R power C. What is C? Minus 1. So R power minus 1. Arrange it. F equals to K M. No need to write 1 power. This is V square. Transfer R minus 1 downwards. So we got the formula as F equals to K mv square by R. This is the formula of centripetal force. We got the relation between physical quantities using dimension method. We are only given that electron is revolving in circular path and a force is working towards center, that is called centripetal force, and this centripetal force depends on 3 components. Force depends on mass of electron, force depends on velocity of electron, and force depends on radius of circular path. We combined, we got an form. We just use the power as ABC and we put the dimension of all the physical quantity. Dimension of force, dimension of mass, dimension of velocity, and dimension of distance. Compare both the sides, we got ABC. Finally, when we put the ABC in this equation, we got a formula. So this was the third and last application. In this way, we can find the relation between physical quantities. Okay, students?